Hi everyone. Today we're going to learn about something called prime factorization, okay, which is a process of breaking down a composite number, which is a number with more than two factors, into a bunch of prime numbers that we can multiply. So we're first going to explore the number 24. And we're going to write multiplication problems that are equal to 24. So in this first box, I could use 8 times 3, or 12 times 2. In the second box, I got to find three numbers, and I got to test it out. I got to play a game. So if you want to try this, pause it, and now we'll look at some of the solutions I came up with. So the top one, I came up with 12 times 2. The second one, I came up with 4 times 3 times 2. You could also do 6 times 2 times 2. And then the bottom one is guaranteed to be 3 times 2 times 2 times 2. Now the order can be different, but you're going to have a 3 and 2 and 3 2's. And it contains all prime numbers. So the bottom row is the only one that contains all prime numbers. And this would be the prime factorization of 24. 3 times 2 times 2 times 2. So what is a prime number? Prime number is a whole number greater than 1 that has exactly two factors, 1 in itself. So 2 or 3 or 11, 71. Can't factor them any further by not using a 1. So the prime factorization is very helpful, helps us find the greatest common factor, the least common multiple, and it's also used in advanced math and topics such as cryptography and coding. Now, when it says find the prime factorization, what it means is find that combination of prime numbers that multiply to get the composite number. And we'll see an example. So I can ask, find the prime factorization of 20. And I like to use the factor tree method. It's helpful for organization. So we start off with the number 20, and we have to find two numbers that multiply to 20. And you're allowed to choose any two you want. The two I chose were 5 and 4. You could also choose 10 and 2, but we're going to try 5 and 4 for this example. Now, an organization technique that I've learned is to circle the prime number. So 5 is prime, and sometimes neither of these are prime, and both of them need more branches. But in this case, only 4 is composite. So 5 we're done with. 4 we continue on. And 4 we break it down into 2 and 2. And I circle them both because those are both prime. So the prime factorization of 20 is 2 times 5. And we tend to write it as an exponent problem. So 2 squared times 5. Both ways are correct, but the right one, 2 squared times 5, looks a little cleaner than 2 times 2 times 5. And some hints to think about when you're doing this. You can use as many branches as you need. It doesn't matter if you find a small number to start, a big number. Okay, a good idea for if we have an even number is always factoring out a 2 first, because our divisibility rules say 2 can go into every even number. So if it's even, we could always start with a 2. Like I said, we should circle our prime numbers. And writing our final answers with exponents, especially if the directions say write your answers with exponents, to ensure that you understand what the directions are asking, how to get the problem correct. And in the future, we're going to use this method and add on to it to find the GCF and the LCM.